Okay.
All right, it's 2 o'clock, so let's get started. A big day, right? Obviously. But homework 3 is out, you haven't seen, and the first part of thing is due not this coming Sunday, but the next Sunday, and then part 2 is the week after. So that's out, so get started on it a little bit. Any questions before we get started? Yeah.
Wait, to reiterate, so the homework 3 part 1 is due this.
No, I said not this Sunday, but the one after.
Oh, okay.
Yeah.
So the one after spring break.
Right at the end of spring break, I think. I think it's the 11th. Any other questions? No other questions at all. I haven't seen it, so. Well, I can't make a DFA for it. But really, any other questions?
Do you know how long roughly it takes to grade all the tests?
How long roughly?
To grade all the tests?
Well, multiple choice is done automatically. But I think I do one question, and they're roughly 340, 350-ish, so 5 to 6 hours for me, for one question.
So for the pumping limit, when we are first reading the question and it gives you the language,
Yeah.
how, like, what's the best way to figure out if, like, in our head, if it's regular or not?
Yeah, so, yeah.
0, 1.
Yeah, so, yeah, it's like you can't necessarily tell whether something's regular or not. So here's just a little bit of intuition. If the number of characters of a certain type depends on the number of characters of a different type, that usually means it's not regular. In the case of equal number of 0, 1, and 1, 0, that's a counterexample. But zeros again, ones again, same number of zeros and ones, so, and we proved that that's not regular. So that's an intuition idea.
Yeah. So, but for the ones that's the same number of 0, 1s and 1, 0s, are we supposed to just, like, know that that's regular?
Well, we showed it, so.
Well, I mean, that specific example, but things like that.
Yeah, it's, we'll try not to deceive you, I don't think. Okay. Any other questions? Yeah.
So just because I kind of lost you there for a second, the last one, you talked about an example where it's not regular, like.
Equal number of 0, 1, and 1, 0, that is regular.
Okay.
And I think equal number of 0, 1, 1, 0 over 0, 1, 2, I think that's not regular. But I'd have to check. But it's not necessarily the counting that's the problem. It's being able to pump out. So if you have equal number of 0, 1, and 1, 0, then I know something about the strings themselves, that they must end and start with the same character.
But is there something that, like, we can like just looking at it that you can tell just by reading the lesson if it's like regular or not with any language?
So here's one. Zero to the end, 1 to the end, and at most 10. Is that regular or not?
No.
Sure. How many strings are in this language? A finite number. What do we know about finite languages? They're always regular. So just because I have the same number of zeros and ones, that doesn't imply anything. But if I did this, what can I say? That's not regular. So, and the good reasoning is from 0 to the end, 1 to the end, and at least 0, I took a finite number of strings away. So if you remove or add a finite number of strings from any language, then whether that language is regular or not stays the same. So if I add or remove a finite number of strings from a regular language, it stays regular. And if I did that with a non-regular language, it stays non-regular. So how about 0 to the n, 1 to the m, and not equal to m? Yeah, it's not regular. How do you know that? Not almost. It's almost. So what he was saying is that this is the complement of this, but is that true? No. No. So let's just say that this is L1, this is L2. Then the complement of L2 is going to include L1, right? Because these strings are not here. But what else is it going to also include? Yeah, so, but if I try to restrict all the strings in L2 bar such that they are zeros followed by ones, then they have to have the same number. So if I intersect with 0 star or 1 star, then this must be L1. Okay. Well, what do we know about that guy?
It's regular.
Yeah, that's regular by definition. This regular expression. What do we know about this one? Non-reg. So can this one be regular? No. So this must be non-reg. Oh, that was telling about L2 bar. I wanted to know about L2. Complement, because if this guy is non-regular, if it wasn't closed under complement, then this would be regular, but since regular is closed under complement, this would be regular too, but that can't possibly be true.
So, like, let's say that we hadn't looked at L1, let's just say the only thing we have on board right now is L2.
Yeah.
If we say that L2 is not regular because it's an infinite number of strings.
Sigma star is infinitely many strings. So if it's finite, it definitely is regular, but if it's infinite, it could be even. Any other questions? Yeah.
How do you go about constructing the CFG for this these kind of strings, like n greater than n greater than n?
So it depends on the language, but let's just say it was this one, and it was n greater than m. Okay? Well, I can spit off zeros as many times as I like, right? So I better have a rule s goes to 0x. I should be able to just spit out zeros in the front. But then I should also be able to go to a point where I have the same number of zeros and ones afterward, right? Actually, I should have a base case of 0 because if I just keep doing this, then I need to stop at some point. But if I get to a point where, okay, now I'm going to have the same number of zeros and ones, well, we know how to do that with the CFG. So let's just have a variable t, and t is going to produce equal number of zeros and ones. And that'll do it.
S0 is not
What's it?
S0 or T0
What do you mean?
in
For
the
this?
family rule.
Yeah. So s is the start, t is another variable.
Okay, I mean to say S goes to T0 or 0T, those kind of rules are not.
I don't need that because I'm thinking of t as making the same number of zeros and ones. So I'm thinking either I can just keep spinning off, I can just have 1 0, that would be in there, or I can have just some number of zeros and then I can stop, or once I stop reading all the extra zeros here, I'll have the same number, zeros and ones on both sides, and t will do that for me. Okay? Any other questions?
Going off that, if S went to T first though, instead of the 0S or 0, you have the same number of zeros.
This is just OR. It's 3 rules.
Right, so if
I
S
just-
went to T alone. that means you're
Oh,
going-
okay, so if you meant like this,
Yeah, then you're.
what's the language of this? 0 to the n1 to the n.
That would satisfy L2 though.
Yeah, it would be L1 now.
Right.
Yeah. Any other questions? Okay. What was the main thing we talked about last week? Chomsky Normal Form. Dougherty. So what in the world is this?
Normal form of grammar.
Yeah, so something to do with grammars, but can you say anything about what the grammars say look like?
Do you want to list off all the rules?
Yeah, so maybe, does it have something to do with the rules of the grammar?
Yeah, that's in certain format.
Oh, okay, they have to be in a certain format. So rules of the form, and so what types of rules am I allowed to have?
Variable, going to two variables?
Right, so I obviously always have a variable on the left side, but I need to go to other variables because I need to get context-free languages here, so I need this. But can I impose anything on B and C?
It can't be the start.
Yeah, they're not the start variable. And we'll see why in a second. What other types of rules should I have?
It goes to the terminal.
Right, if I don't produce terminals, then I'm dead in the water already. But what other rules may I have?
S goes to epsilon.
S goes to epsilon where?
S
is the start symbol.
S start variable. So whatever I call it, the start variable goes there. Okay. Well, why do we do this in such a roundabout way? Why don't we just say any variable goes to epsilon and any variable goes to any other two variables? Why would I want it like this? What am I trying to limit?
Start variable being on the right-hand side.
Yeah, well, yeah, the start variable on the right-hand side, so maybe there's some circularity that I'm omitting.
The number of derivations.
For what string?
There's one.
Yeah, so by limiting it this way, the only way to make the empty string is this way. I can't come back to the start variable, right? Because it's not on the right-hand side. But why would that be important? Well, that must mean in the derivation, no variable can produce epsilon. Because the only way is with the start variable, and we can't get back to the start variable. So every variable that we make is gonna make something of the string. So it severely limits how many rules, and it'll be, we can actually figure out exactly how many rules we need to apply in order to get the string that we want. Okay, so that's a really nice property. But what did we show about CNF? Can any grammar be converted into this form? Can any CFG? Yeah, we described an algorithm that took any CFG and produced one in this form, but what do I know about that grammar and the original one? They have the same language. If they don't have the same language, then I can't conclude anything. So they have to produce the same language. But what were the steps that we did in order to convert a grammar into CNF? Yeah, I better not have a start variable on the right-hand side, so let's make sure start variable not on right-hand side. Okay, that seems simple enough. What was the next step that we did? Yeah, so I'm going to put this in quotes, so-called eliminate epsilon rules, because obviously if I just destroy all the epsilon rules, if the start variable makes it, I don't care about that one, but all the other ones, if I just omitted those, then I could change the language. Like, obviously here, if I omitted this one, what would the language of this grammar be if I omitted A goes to epsilon? Empty set. Because every single other rule has a variable on the right-hand side, so it can't produce any string. So I can't just straight delete them, and then we'll see how to do that. But what was the next step? Eliminate, what's a unit rule?
There's only one variable on the right-hand side.
Right, exactly one variable and nothing else on the right-hand side. So unit rules. And we have one right here, S goes to B. And why would I want to delete remove unit rules?
They're unnecessary.
They're kind of unnecessary, right? Because if I say S goes to B, I might as well have just done S straight down to the things on the right-hand side of B, right? It's like, it's serving no purpose to me. So we're going to eliminate those. And what was the next step?
One variable or one terminal.
One terminal, nothing else, or two or more variables in brackets.
Right. So I'm going to, basically, I remove all of the mixing of variables and terminals to just make it just S goes to epsilon, or just a single terminal, or a whole bunch of variables, right? So ensure right-hand side only S, well, I guess that's not quite right, but single terminal or at least two variables. Okay. So we're almost there. What's the thing I haven't done yet? Right. The first two parts of this, they follow the form I want, but I said at least two here, but I want exactly two. So I know it's sad, but break up long right-hand sentence. Seems simple enough. Any questions about this? And first of all, why am I doing them in this way? Why don't I do, say, 3, then I do 2, then I do 4, 1, and 5? Why do I do it in this way? Right. If I do them in a different order, then I may reintroduce problems I had before. Like, let's see, what would be a good one? If I eliminated unit rules and then made sure start variable is not on the right-hand side, that introduces a unit rule. And so I'm back where I started. So I do it in this way so that I, first of all, don't change the language in any step, and I don't reintroduce problems I had. So let's convert now a grammar to CNF. And just a little bit of word of warning, this will get big. So just leave lots of room. Use the back if you want, I guess. But I have this grammar. S is the start variable. A and B are other variables. And little a, little b, little c are terms. And I want to convert this to CNF. Because, oh, yeah, I should have mentioned the importance of CNF. So why do we care about CNF?
Makes the first and follow sets easier.
Yeah, it makes the first and follow sets easier, but what's another one? And it also reduces the problem with epsilon being generated in multiple ways and makes sure that every variable generates something, but what's another way? Another thing that's important.
Makes the parse tree binary.
Yeah, the parse trees are binary, right? Because if you consider a parse tree for a grammar in CNF, every variable is going to be some node. Either it has exactly one child, in which case that would be a terminal, or it has exactly two children because of this. So it's a binary tree. And I think those are pretty good reasons. So let's convert this to CNF. So what was my first step?
Start variable.
Yeah, make sure start variable's not on the right-hand side. So I'm going to write this step 1. And so I'm going to, should I change any of the other rules? Oh, and actually, first off, is the start variable on the right-hand side of any rule?
Yes.
Wow, that's unanimous. All right, it has twice on the right-hand side, so we should pick that. So what I'm going to do is make a new start variable, S0. So this is my new start variable. It's going to produce what?
S.
S, good. And then I'm not going to change the other rules. B, A, C, S, or epsilon. B goes to A, S, A, or B. So let's make a check after each step. Did I change the language of the grammar?
No.
Well, you can just say no, but let's see why. Right. Well, let's see. Consider any derivation in this grammar. Can I get one in this grammar? Well, what I could do is just whatever it was, just prepend S0 goes to S at the beginning. Because I know the derivation starting with S, I just need to know how to use S0 to my advantage, and I know how to do that. But what about the other way? If I have a derivation in this grammar, can I get one in the original? Well, yeah, since the derivation must start with S0 goes to S, since S0 is the start variable. So whatever it is, just take off S0 goes to S, and now I have one for that grammar. So I didn't change the language. Cool. Any questions about that? So let's do step 2, which is what?
Eliminate epsilon on the right side.
Yeah, so I want to eliminate, quote unquote, the epsilon rules. A better word for this, and one that you should think about, is simulate epsilon rules. And why is that? Well, I want to not change the language. So what am I going to do? I'm going to replace A goes to epsilon, so I will eliminate that rule, but I'm going to add other rules as if I'm going to simulate it. Okay? So what was our method to actually do that? What's that? Yeah, the nullable variable. So what is a nullable variable?
Variable that can go to epsilon.
Right, so a variable, so this is a variable that can produce the empty string. So either directly or indirectly with other rules. So what is a nullable variable straight away? A is 1. All right, so here's my list. I'm going to have A there. Are there any other nullable variables? S, yeah, because since A can produce epsilon, well, from this right-hand side right here, S can produce epsilon. So I need to make S nullable. Any others? S0 is 1 because since S I just determined can produce epsilon, so can S0. So I better add that. Any others? No, I don't think B is the only other candidate. Well, let's see. A and S are on my list, so they could drop out, but I still have a terminal here. And here, I haven't even determined if B is nullable yet, so I can't use that to my advantage. So those are my nullable variables. Okay, well, I found the nullable variables. What am I going to do with them? Well, I think a suitable idea is just to keep the original rules and simulate as if they went away. So let's see. So I have S0 goes to S. So I'm not going to remove any rules of this grammar, even the A to epsilon 1 yet. But, so here, S can go away, so what rule should I add? S0 goes to S. Good. So I'm simulating as if S went to empty. So far, so good. S goes to, well, I better keep exactly the right-hand side. All the existing rules, no changes. Okay, well, is A nullable?
Yes.
Yeah, so how many possible rules could I be adding here? Three. I think it's 4. 2 choices independently for the first guy to drop out, 2 or more for this guy, 2 or more for this guy. How many is that? I think it's 8. But the nice thing here is that they're all the same variable, so I'll have a bunch of duplicates. So I don't need to write them all down. So don't worry, I'm not adding that many yet. So I have the case, these 3 A's, where they're all present because they could make something that's not the empty string. Well, I may have a choice as to one of these dropping out, in which case I have 2 A's left. So I better add the rule AA. But I also have the choice of where 2 of them dropped out and 1 of them stayed in. So I should have a single A. And then I also have the choice where all 3 drop out, in which case I'm going to put epsilon. Don't worry, I'm going to get rid of it. So we handled all possible ways for this one. Now I go over to here. A is nullable. So I handled the case where capital A is present. I need to handle a case where it's not present. So what rule should I add? Lowercase a. All right. So I handled that one. What about this one? Even if it were nullable, I already have it covered with epsilon anyway. So we're done with that one. Okay. A goes to B, A, C, S, or epsilon. I will get rid of it. Don't worry. So which of A or S is nullable? Both of them. So how many rules should I add?
3.
Just start counting up, right? Eventually you get it. Well, I gotta handle the case where all of them are in, exactly one of them is in, or both of them are absent. Okay? If I had n variables, I need to make 2 to the n rules, in general. Here I didn't need to because I had copies, but in general I need to do that many. So here, I need to make the case where, let's just say A drops out and S stays in. So I have B, C, S. I need to make the case where A stays in and S drops out. So I'm going to make B, A, C. And I need to make the case where both of them drop out, which is just little b, c. Okay? Epsilon, that's already taken care of. So now I need to do the B rules. So B goes to keep the same things as before. So which of A or S is knowable? Both, again. So I need to do all 4 possibilities with this guy. So it could be the case that A drops out, S stays in. So I make S A. Make the case where A stays in and S drops out, in which case is capital A, little a. And then the case where both of them drop out, in which case be little a. So I handled this one. Do I need to worry about that one? No, why? A is not null. So I think I'm done for the most part. So what do I need to do now? Get rid of the epsilon rolls, other than S removal. Good. So get rid of that one, and that. Those are the only ones. Okay. So let's check. Did I change the language while doing this? Well, let's see. Suppose I took A to epsilon here. Well, if I look over here, I simulated all the possible ways A could have dropped out. And so therefore, I didn't change the language. So that's pretty cool. And you can see that we're getting closer. We're starting to get only epsilon up here. I still have a mixture of things, but it's much more structured than before. Any questions about this? What's the next step? Eliminate unit rolls. All right. Let's do it. Step 3, eliminate unit rolls. So first of all, do I have unit rolls?
Yes.
Yeah, I have a few. I have S0 goes to S, S to B, S to A. I have unit rolls. So how am I going to fix this? Yeah, so this directed graph thing. So what is that graph supposed to model? Or rather, what are the edges? The unit rules themselves. Okay? So I'm going to have 4 vertices, S0, S, A, and B. And I'm sorry to say this graph will be incredibly disappointing, but let's put the edges in. So what edges should I put in?
S0 to S.
S0 to S,
S to B.
S to B, because that's a unit rule, S to A. And those are the only unit rules. Okay? Let's see. So how is this graph going to help me?
You can add the rules from A to S.
Yeah, well, let's see. What do we know about A and B in terms of this graph?
They're on the right side, right?
They're, what are they called? Starts with an L.
Leaf.
Leaves, right? Because they don't come back to any of the parent vertices. So I know about those that they don't have any unit rules. So a suitable idea might be to copy and paste the rules of A, the right sides of A, up to the one for S, and then eliminate that unit rule. Okay, that's a good idea. So let's just build this bottom up. So I'm going to do all of these rules first. B or SA or, and this is where the graph gets big. So A produces BACS or BCS or BAC or BC. So, well, the ones that are non-unit rules, I think I should keep those exactly the same because they may make something that a unit rule might not. So the non-unit rules I'm going to keep there. AAA or AA or B I'm not going to put in. 2 A's, single A I'm not putting in, little a. Okay. So now what is a suitable idea? Well, if I was to take S to B, then essentially what I said before is we can just copy and paste the rules of B up to here. So let's do that. So A, S, little a, BB, or SA, hopefully I don't make a mistake, or AA, or little a, thankfully is already there, so I don't need to add it. So we took care of the B edge. So now, what do you think I need to do? Take care of the A edge. Okay? So, or this pad, which is BACS, or BCS, or BAC, or BC. Okay? So we took care of the A edge. Now what do I do?
S0 generates S.
Yeah, S0, and then since that's a unit rule, I need to add these things up here. So what do you think I can do instead? So instead of rewriting all that. Did I do everything correctly? Ah, yeah. So something that you should be very careful about is if there's an extra rule, you may delete it if you just saved it or whatever. Okay? But that's the essential idea, and we took care of it. So all we're doing is just doing simulation of the rules. Okay? The simulation of the unit rule just by copy and pasting things. Okay? But any questions about that? What's the next step?
Create non-terminals that generate the terminals.
Yeah. So we want to get down to a point where I have just a single terminal or just two variables. Well, it may be a lot to ask to just have two variables. So maybe what we can do is just a single terminal or a bunch of variables. Okay? So that is, I guess I'll put here, step 4. So what should I do? Make new variables? Yeah, make new variables for each of the terminals. And I think the terminals are lowercase a, b, and c. So I'm just going to make up names. Use of A is going to produce A. Use of B is going to produce B. Use of C is going to produce C.
Oh wait, can they replace it?
And where should I replace the terminal with the corresponding variable? What was that? Everywhere they're mixed, right? Or really any right-hand side that has length 2 or more. So if it was just exactly 2 terminals or more than 2 terminals, then I should replace those 2. Or I guess those 2 or more. But anyway, let's do B. And so that's A, S. And then since it's a mix, I'm going to replace it with use of A. And note, I did that not on purpose. And another funny thing is that use of A is so incompetent they can only produce 1 character. So it's so funny, right? All right. So let's do the other one. Capital B, use of B, or S, use of A, or A, use of A, or should I replace that lowercase a? No, what would that introduce? Unit rule. So I'm going to leave that alone. All right, so A is going to produce use of B, A, use of C, S, or use of B, use of C, S, or use of B, A, use of C, use of B, use of C. Okay. S is going to produce AAA, or use of AA, or AA, or single terminal, AHU again. B, use of B. S, use of A, use of A, or, I know it's long, use of B, A, use of C, S, or use of B, use of C. So I'm not rewriting this for the 5th step, but or use of B, A, use of C, or use of A, use of C. Hopefully I didn't make a mistake. And S0 is going to be ditto, or empty. Okay? It's getting pretty big. So let's see. Did I change the language though? If I didn't make a mistake, obviously. But did I change the language?
No.
Well, again, we can just say no, right? Well, let's see. So if we take any derivation in that grammar over there, well, if it ever uses a rule that we didn't change, then obviously there's no change. But if it used a rule that we changed, then it will have the corresponding variable, at which point we can just apply that variable, it goes to the corresponding character. So it really does give exactly the same strings. So I have no problem here. Okay? Any questions about that? What's the fifth step?
Break up long right hand side.
Break up the long right hand side. So after this step, you'll think I'm crazy for writing all this out.
We are better.
I'm already crazy, right? All right. So, well, do I have a long right-hand side? Yeah, so how do I find what's a long right-hand side?
Three or more
I have 3 or more variables, and I definitely have that. I have some with 4, so we have some work to do. So, how am I going to fix that? I should add new variables that go to 2 of them, and then I should add new variables and have those go to exactly 2 of the long right-hand side. Okay, so let's see. So if I did it the way we're supposed to do it, it'll take the rest of the time. So I'm just gonna do it this way. So S0 goes to AAA. I'm gonna replace it with something. So what should I replace it with? Well, we should have a variable make 2 of these guys. I could choose either the first 2 or the last 2, it won't matter. So I'm gonna have it go S0 produces, I'm gonna call it X1A, and X1 produces AA. Yeah.
Do we, so like on the test, would we need to say like all of this, or can we just write a new grammar and then just have that rule that X1 goes to AA?
You should put the words of what the step is.
If we do that, yeah, if we do that
That
first,
should be
like,
fine.
but then, so you're writing S0, so you're saying I'm replacing this.
Yeah, I should
rule.
say step 5 and then break up long right-hand sides. You should say introduce the new X variables as new variables and delete this rule, replace with those rules.
So that's a lot to say though in a limited amount of time. Could we, so if we just say, you know, break up right-hand rules by, that are 3 or more variables by introducing new variables, and then just write it all up.
That should be okay.
That'd be fine.
Is there like a naming convention for adding these new variables?
None. The way I do it is either choose X or Y and then just add 1 to the subscript every time. Yeah, there's a question over here. I guess not. Okay, so we fixed that rule. So let's do so this rule's okay. I'm thinking S0 goes to the ditto part. So these 2 are okay, this is okay, this is okay. Oh, this is not okay. So I gotta fix S0 goes to A as use of A. And then, so now I should add a brand new variable. So I'm gonna replace this with, I'm gonna call it X2, and then the last thing, which is use of A. And then X2 is gonna make A. So what I should do here every single time is to make a brand new variable every single time, but I'm gonna do that, I'm not gonna do that for interest of time. It's not gonna change anything. So let's see. We did S0 goes to this guy. We're done. So that's good, that's good, that's good. Oh, this is not good. So I should make S0 goes to use of B, A, use of C, S. So how many new variables should I be adding here? 2, yeah, because each one's going to eliminate 1 of the things on the left, so I need 2 of them. So I'm going to have S0 goes to X3, last guy here, which is S. And then X3 is going to produce these first 3. So it should produce something called X4 with use of C. So x4 u sub c, then x4 is going to make u sub b. Okay? So to handle that, let's handle this one. So S0 to UV UCS. So I need to add a new variable. S0 goes to X5S. X5 is going to do UV UC. Need to do the second to last one. S0 goes to UVA UC. So S0 is going to make X6 UC. X6 is going to make UVA. Yeah.
In that case, instead of using X6, that we use X4.
Oh, I should do X4, yeah. I should, for the interest of, for correctness only, to use a new variable every time, and I can explain why at the end, but for the interest of time, I'm going to use variables that I've already used.
But this would be correct.
Yes, this would be correct. Yes, this would be correct. Because X4 is going to only be on the left-hand side of one rule. So once I entered, say I apply this, X4 only has one option to do. So that should be fine there. All right, so I think S0 is good. S will be replaced. S is rules, I guess. Placed the same way. Because the long right-hand sides of S are the same as those of S0, so I'm going to have the exact same rules, but with S instead of S0. Okay, so let's do A's rules now. So A goes to, oh, we got a long one already. So I think I have UV, so UV AUCS, that's going to do the same thing as number 3. So I'm going to number these, I guess, number 1, number 2, number 3, 4, 5, 6. With A on left-hand side. Because if I just did the same thing, then I just deleted the rule of A. I can't have that. So A to UV UCS. That's the same thing as number 4 with A on the left-hand side. A goes to UV AUC. So what's the disadvantage of using things in CNN?
Really long.
A lot of rules. So that's a real disadvantage. Do I have that one? Yeah, so number 5, same thing. And the last one of A is good, so we're fine there. B to A is U of A. Do I have that one? That's number 2 with B on left-hand side. B to, do I have another one? Oh, that's it. Cool. Did I change the language?
No.
Again, let's prove it. So this would be a lot easier if you make a brand new variable every single time instead of using old ones like we do here. So let's assume I carried out through everything and I made a new variable every single time. Well, if I use one of the rules I didn't replace, then that's not going to change. I keep those rules. But what if I use the longer one? Well, if I use the longer one, that corresponds to exactly one rule over here. And the nice thing is that if I choose, say, x1a, I have no way out other than using x1 to AA. X1 only appears on the right-hand side once and on the left side once. So once I enter that, use that rule, I can never use it again. So that's a nice property. Yeah.
Did you say that each rule down there pertains to one rule?
No, only so I keep all of the existing rules except the ones with long right-hand sides.
Okay.
I delete those and replace them accordingly.
Okay.
Yeah. So the ones that are up the form, those are fine already. I shouldn't care about
But
those.
one of those rules on the bottom there can represent even 2 or 3 rules up there.
Like which one?
Well, like, for example, the ones that have 4 variables,
Uh-huh.
like that one, for example, you would essentially need 2 rules up there to replace it, right? Because
Yeah, so I'm going to replace it with 2 rules. Yeah.
So you're saying when we used, like, say, x sub 1 to generate AA for S0, we could not use the same x sub 1 and the S generates AA?
No. Well, if I replaced it with x1, I just made a unit rule.
Yeah, well, the AAA, though, on the very left?
I could. I'm just saying for correctness, it's a good idea. There's no difference, since the only reason is that this works, if you did this replacing like it did here, is that x1 only appears on the left side of 1 rule. So once I use x1, I only have 1 rule to use.
Yeah.
And so since those variables are exactly the same, it doesn't change anything.
Okay.
But it's just easier for correctness reasons.
But if I put that on an exam, if I use the same x1,
Hypothetically.
so I should make a second one?
If you have time, yes. But if you don't, then I say just reuse variables.
Okay.
It was fine for wherever it went, step 4, because these variables that we added only make 1 terminal.
Yeah.
And so they don't go anywhere else other than that.
Yeah.
So it was fine using the same thing over and over here. It just seems weirder because variables can make other things.
Yeah.
So that's why. But there's nothing wrong with it.
Okay.
It helps prevent making mistakes.
Definitely.
Yeah. Any other questions? So we didn't change the language, and I think we have something in Chomsky Normal Form.
Cool.
Nice. After our blood, sweat, and tears, right? We eventually got something. Any questions about these 5 steps and how we were able to do it? So let's do the second question. So I made a slight typo for the second question. It should say a context-free grammar in CNF. Yeah, so this does not work for arbitrary CFGs, but it does for grammars in CNF. So it says that if we have, I'll just write it down. CFG G in CNF, we have a string W that the grammar can derive with the length at least 1. So I'll say why this has to be at least 1 in a second. So non-empty string, and so show that any derivation using G's rules takes 2n minus 1 rule applications. So this is really nice, if we can show it. But it's nice in that we know exactly how many rules will be applied. Whereas for any old grammar, we might not necessarily know. And I could show you one that contradicts this. But that's a nice property. So how would I go about showing that? Yeah.
When you start, basically,
Well, I have to use the start variable, obviously. But
well, I was going to say that you start by saying that for every character in the string, it must have been created by a rule.
yes.
Therefore, there are at least n number of applications of rules by that.
Yeah. So let's look at the rules for a second. These are the only types of rules that we can have. So since it's not empty, then the only way we could have made an empty string was with this way, so I can ignore that rule for now. If I have a length n string, well, each of these variables that I'm going to produce must produce something of the string, right? So one derivation would be just keep adding, applying rules such that I have n variables in a row, and then have each one of them drop out to the corresponding character. So let's see. So let's say that it produces A, B, and then it produces something else, and then it produces variables, say capital W1, capital W2, up to capital W9. So what these represent are, this variable has a rule that can replace it with the first character of W, this one with the second character of W, all the way to the last character of W. Okay? Well, if that's one derivation, well, how many steps does it take to get to there? N minus 1. Why is that? Well, I start with one variable. How many do I add every time? One, right? Because I replace one variable with 2. So I start with 1, and I got to get to n. I add 1 every time, so I have n minus 1. So I have n minus 1 to get to the thing that just has all variables. But now I got to get to the thing that has all terminals, the string w. Well, how am I going to do that?
Each
Well,
W of whatever
Yeah,
drops out.
every single step, I'm going to remove one of those variables. So little w1, capital W2, and then I go all the way until I have every single term. Well, how many rules does that take? Exactly n, because each one, I can only remove one variable to its corresponding terminal, so this step takes n. Hence, 2n minus 1. Okay? Would the empty string fall in this, under this umbrella?
No.
No, why is that?
It'd be -1 rule applications.
Yeah. I can't have -1 applications of rules, right? So, how many rules does it take to make the empty string if it's in the language?
1.
1. And how do you know that? Because the only way to make it is with the start variable. So, that's why I say for any non-empty string, it takes 2n minus 1. For the empty string, it takes exactly 1. Nice. Any questions on that? Yeah.
Just to clarify, the n minus 1 is because s, you're basically removing the s.
What's that?
The n minus 1 is because of the s, right?
From s to a whole bunch of variables which will drop out to the corresponding term.
Yeah.
Yep. Any other questions? I guess we'll see you tonight.